Okay, today we're going to talk about parametric equations. So we've got basically parametric means that we've got a parameter or a new parameter, and often that parameter is t. I'll just give you an example. So we've got a ball, we're going to throw that ball and it's going to follow this path and eventually hit the water down here. Okay, so we could define our geometry system like this, Cartesian system. We'll call this y and we'll call this x, and it follows this path, x and y, but the parameter of time suggests that it's not, it's in a particular spot at any one time. So we could say x is its x position has a variable t, and so does its y position as a variable t. So the height changes with time and the x changes with time. So it follows this path, and we could find the equation of this parabola if we wanted to in terms of y and x, but we know that at different times, the parameter t, it's going to be in a different spot. Okay, it's going to have different coordinates at different times. Okay, so that's the idea. We've got, we're going to do it with vectors. Though we've got position vectors. So let's do an example. We've got the position of r, right, as a function of t. So both the I and j components are functions of t. We could have t minus 1i and plus t squared j. Okay, so t minus 1i plus t squared j. Okay, so at any time, its I component is a variable with t, and its j component also a variable with t. So what would be the Cartesian equation for this? Okay, so basically our I components have to equal x, so we go x equal t minus 1, and our y component is t squared. Okay, so we want to somehow combine these, so we cancel out the t's and we end up with just y's and x's. So we're trying to find the Cartesian equation for this by removing the parameter t. Okay, so let's rearrange this for t, this x1. So we add 1 to both sides, we get x plus 1, and then we'll substitute this t in for the y. So we get y equals x plus 1 squared, and that's it. Okay, so now we know the Cartesian equation. It's a parabola. Now, if we were going to draw this, we've got to make sure we take into consideration the t. Okay, so at t equals 0, time equals 0, we get x equals negative 1 and y equals 1. So this point, right, we get x equals negative 1, okay, and y equals 0. So we'll write that as a coordinate, okay. And then as t progresses, x gets bigger, yeah. So x gets bigger as time progresses. So it's going to be just this half of the parabola. It's going to turn around there, but okay. So we've got, it's this equation, but it's only for x greater than or equal to negative 1. Okay, so getting that domain right is really important. Okay, let's do one more. Okay. What have we got? What if we've got RT equal to 1 plus cos of t I plus 2 sine of tj. Okay, so this one, which often happens, we've got sine and cos in our, our trig functions for our components here of a vector r. Yeah. Okay, so we do the same process. We say, well, x has to be 1 plus cos of t, and y has to be 2 sine of t. Now how are we going to combine these to get rid of our parameter t? Yeah, okay, so we need to find some sort of relationship between sine and cos to be able to do that. Okay, so let's rearrange these so we get cos of t and sine of t on their own. So we want cos of t equals, well, that's going to be x minus 1. Okay, sine of t, that's going to be y divided by 2, y over 2. Now, we can't put these together yet, but what if we square both sides? If we square here, so we get cos squared equals this squared. We know sine squared equals this squared. We know sine squared plus cos squared, that's got to equal 1, yeah? Okay, so we know the identity sine squared x, well, I'll do theta, plus cos squared theta has to equal 1. So here's a relationship that we can put sine and cos into. We know that that's the case. So that means this plus this has to equal 1. Okay, so we've got, I'll do the x's first. I'll write these around the other way. X minus 1 squared plus y squared on 4, expanding that out, has to equal 1. So we're going to get, this is an equation of ellipse, yeah? So we're going to get an ellipse. It's been, you know, we've got it stretching by a factor of 2 here, and you know, moving to the right 1, moving to the right 1. Okay, and there we go. All right, that's it for today.